Welcome to Geometric Sequences. This is from your homework, page 814 to 816, 1 through 23 odd, 29, 31, 39, 41, 57a, and 59. So let's take a look. We've already looked at arithmetic series and sequences. Those were specific cases in which our numbers went up by a common difference. So we either added or subtracted the same number every time. In a geometric sequence, we are either multiplying or dividing by the same number every time. However, in a geometric sequence, we always want to write this as a multiplication. We call that the common ratio. So what number are we multiplying by every time to get to the next term? Let's take a look at number 3. So now that we've discussed the definition, let's tell whether the sequence is geometric. Explain why or why not. Well, remember, we said that if it's geometric, it has to be multiplied by the same time. So let's look specifically at multiplying. How do I multiply to get from 1 to 4? Well, I would multiply here. I would go times 4. How do I get from 4 to 8? Well, I would multiply by 2. From 8 to 16, I multiply by 2. And 16 to 32, I also multiply by 2. Now this one's tricky because after the first term, it seems to be a geometric sequence. But because the first two terms are not geometric, I multiply by 4 and then I multiply by 2. This one is not geometric. To explain why or why not, I would say that there is no common ratio. There's no number in which I multiply the previous term by to get the next term in all cases. Okay, let's move on to the next problem. Here it says write the rule for the nth term of the geometric sequence, then find the 7th term, or a sub 7. So they're giving you a sequence, and then they would like you to find write the rule for the nth term. So I kind of wrote the general rule over here. A sub n, or my nth term, is the first term times the ratio to the n minus 1 power. So what we need to identify is the first term and the ratio. If I can get both of those, I can write the nth rule. So here, I need to first figure out, well, my first term is easy. It's 1. Just take that first term and write it down. The ratio, again, I have to figure out what am I multiplying by to get from one number to the next. Well, here I multiply by negative 4. Here, to get from negative 4 to positive 16, I also multiply by negative 4. And to get from positive 16 to negative 64, I'm also multiplying by negative 4. So our ratio is negative 4. Now I have the two things that I need to write the rule. So my general rule is a sub n equals the first term, 1, times negative 4 to the n minus 1 power. So this is the first part of my answer. The second part of my answer is finding a sub 7, or specifically the 7th term in the sequence. So I plug in the first term, 1, the ratio, negative 4, and the number that I'm looking for, the 7th term, so 7 minus 1. So a sub 7, 1 times anything is that thing, so I'm going to just, don't really have to rewrite the 1 down, but I'm going to take negative 4 to the 6th power. Now, if you're anything like me, you're going to have to get out your calculator and calculate what negative 4 to the 6th power is. I do know it's going to be positive because I have a even exponent, and when you calculate that out, you get 4,096. So this is the second part of the answer for number 15. Okay, let's take a look at one last problem. Number 31. The directions say write the rule for the nth term of the geometric sequence. Then graph the first 6 terms of the sequence. So again, I put the general rule for the nth term, and they give us the second term and they give us the ratio. But I need the first term and the ratio. So I need to use this information to find the first term. Well, if I know the second term and I know the ratio, I can simply take that term, the second term, to find A1 and divide it by the ratio. Well, 15 divided by 1/2 is really the same as 15 times 2, and that's 30. The reason I'm dividing by the ratio to go to A1 is I'm going backwards. Instead of multiplying to get to the next one, I'm dividing to get to the previous one. So now that I know my first term and my ratio, I can plug these into my nth rule. So this is the rule for the nth term. That's the first part of my answer. Now they're asking me to graph the first 6 terms of the sequence, which means I need to calculate what those first 6 terms are. I already know that my first term is 30 and that my second term is 15. Those two were given to me up here. And now I want to calculate the third term. So I'm going to do 30 times 1/2 to the 3 minus 1 power. Well, that will give me 7.5, 7.5. Then I'm going to calculate the fourth term, which is 30 times 1/2 to the 4 minus 1 power. Now, knowing that my ratio is 1/2, I could just multiply the previous term by half. And that's what I've been doing in my head. I take half of 7.5. Well, half of 7 is 3.5, and half of 0.5 is 0.25. So this is going to be 3.75. Finally, my last term, 30 times 1/2 to the 5 minus 1 power. And now I'm taking 3.75 and multiplying that by half. And that is 1.875. So now I'm going to go ahead and graph these. Here's a little graph that I already set up. On the bottom, I'm going to have my n's, and then on the side, I have my a sub n, or the result, the value. My first term's value was 30. My second term's value was 15. The third term was 7.5, so here I've got 3, 6, so what's 7.5? My third term was 3.75. My fourth term, excuse me. And my fifth term was 1.875. And then it did tell me to do the sixth term, so let's go ahead and quickly calculate that. I'll have 30 to the 1/2, 6 minus 1, which is really just 1.875 divided by 2, which is 0.9375. So that's going to be a little bit less than 1. If you have any questions on geometric sequences, please see me or Mr. Daniels, and have a fabulous day.